In this video, we will discuss about the second application of hygen principle, that is laws of refraction. We know that the laws of refractions are, first one is incident ray, normal and refracted ray all lie in same plane, and sine of angle of incidence to the sine of angle of refraction is equal to the relative refractive index to which it goes with respect to the medium from where it has come. Now, to understand the laws or refraction by hygen principle, I have drawn this diagram. So this is our any interface. It's a line which separates the two mediums. I take this is your first medium having a refractive index n1, and this is your second medium having a refractive index n2. Since both are the different mediums, so their velocities will be also different. So I take this velocity as a v1 and this velocity as a v2. I suppose that the velocity v2 is less as compared to v1. Now let us see here a beam of light incident on this interface. So if I take this one, or in terms of wavelengths, this is your wavefront. Wavefront is always perpendicular to the direction of propagation. So this is your direction of wavefront. So as the wavefront emerges out, the incident light also moves forward. So as this wavefront strikes or reaches at this point, it strikes this interface. This part of the beam is, or this part of the wavefront strikes the interface. So I take this as a incident wavefront. मैं इसको इंसिडेंट वेवफ्रंट लिखता हूं. This is your A and this is your B, incident wavefront. Now, according to the hygen principle, each and every point of this incident wavefront act as a source for the secondary disturbance. Next disturbance happens because of this wavefront. Now, as the light emerges out from this wavefront, or I want to draw the wavefront at a later time, so let us suppose the light takes tau time to reach from B to C. I take this point as a C. Then this BC distance will be equal to, if the velocity in this medium is equal to V1 into tau. Now I want to draw the wavefront after the time tau. So I have to draw the wavelets at each and every point on this incident wavefront. Since the velocity is different in different medium, so the wavelet radius will be different. For example, see here the light is traveling wholly in this medium. So its radius will be V1 tau. This part A, the light has gone to the other medium having a velocity V2 and it is less than V1. So the radius here will be equal to how much? The wavelength will be V2 tau. So this part will be less one. So here if you want to draw the wavelets, this wavelet will be of bigger one size and this wavelet will be of a smaller size. Look at these wavelets. अगर मैं इनमें tangent draw करता हूँ, tangent to this wavelet represents our secondary wavefront and it is known as refractive wavefront. So I take this part as a D. We know that the light emerges out perpendicularly. Light emerges out perpendicularly to the wavefront. So the light will be along this direction. So this is your refracted light. So from here you can see that when a light or beam of a light goes from one medium to the second medium, it bends from its path. Now let us verify this one. So this part of the length is V2 tau. Now let us verify this laws of refraction. So first I have to calculate what is sin I, what is sin R. To calculate sin I and sin R, first designate. So if I draw a normal, I am drawing, this is our normal, and this angle made by the incident ray with the normal is known as the angle of incidence, and angle made by the refracted ray with the normal is known as the angle of refraction. So if this angle is our I, this angle, this will be your also I, and this is your R, this will be also equal to R, because angle made by the two lines and their perpendiculars will be equal. So see here, so this is your 2 1, these are two lines, so this is your incident angle. So normal के perpendicular कौन है? This line, and इस line के perpendicular कौन सा होगा? The wave front. This is your direction of incident light, और इसका क्या होगा? Normal wave front. So this angle is your angle of incident. Similarly for this also, ये तुम्हारे पास wave front है, this is your incident ray. So ये दोनों आपस में क्या है? 90 डिग्री, और इस लाइन के नॉर्मल के परपेंडिकुलर कौन सी लाइन है? This one. So इन दोनों के बीच में जो एंगल होगा, that is also equal to the angle made by the two lines. So this is your angle R. So from triangle ABC, so this triangle A, B, and this triangle, this part of the triangle. In this triangle, what is sine theta or sine I from here? What is sine I from here? The sine is front side, this is BC divided by AC. So we know that BC is equal to how much? It is V1 into, what is the value of BC? BC is equal to V1 top divided by AC. Now from triangle ABC, so what is sine R? The sine R will be equal to how much? This is your sine R. Now this triangle, only this part, this one triangle. इस triangle में for this triangle I am going to calculate what is sine R. So sine R is front side, that is AD divided by AC, hypotenuse. So AD is from here. So this is your radius of this wavelet. The radius of wavelet is what? V2 tau. So it is V2 tau divided by AC. So taking your ratio, so from 1 and 2, I take this as a 1, this as a 2, from 1 and 2. So what you get? Sine of angle of incidence to the sine of angle of refraction is equal to V1 tau divided by AC, V2 tau divided by AC. So AC get cancelled out, tau get cancelled out, you are left with V1 divided by V2. So this is your ratio of sine of angle of incidence to the sine of angle of refraction. Now I want to write this law, or ratio of sine of angle of incidence to the sine of angle of refraction in terms of refractive index. So I want to find out the relationship between the refractive index and velocity. So we know that refractive index is given by the speed of light in vacuum to the speed of light in a medium, where we want to calculate the refractive index. We know that the speed of light in vacuum is always constant, and its value is 3 into 10 raised to power 8 meter per second. So this is your constant. So if it is constant, so can write refractive index is inversely proportional to the velocity. If I want to calculate refractive index for v1 velocity, so it will be n1. So similarly, n2 will be equal to how much? It is proportional to v2. n1 or v1 has an inverse relationship. So it is in numerator, so it will be in denominator. So it is in denominator, here it will be in the numerator. And it is in the ratio, so it is no problem, the constant can be cut. So next one is, it is nothing but is the relative refractive index, the refractive index of 2 with respect to 1. So from here you can say that the sine of angle of incidence to the sine of angle of refraction is equal to relative refractive index and or refractive index to which the light goes in second medium, from where it has come, that is n1. So here it is n2 divided by n1, and if you want to write in terms of velocity, it is v1 divided by v2. Furthermore, if you want to enhance further, I want to write this Snell's law in terms of wavelengths. So how will you write it? So we know that velocity of a light is given by frequency of a wave into wavelength. When a light goes from one medium to the second medium, a light going from one medium to the second medium, the frequency of a light remains constant. If a light is going from one medium to the second medium, the frequency of a light remains constant. जो frequency होती है light की, वो हमेशा constant रहती है, it does not change. तो ये term क्या होगी आपकी constant. So velocity is proportional to wavelength. For what? When a light goes from one medium to the second medium. Condition ये है कि observer or source, either they are rest position or they do not have any relative motion, or relative motion between them is equal to 0. So then velocity directly proportional to the wavelength. So it is for v1 velocity, the wavelength will be v1 lambda 1. For v2, wavelength will be lambda 2. So put the value, so you will get it is lambda 1 divided by lambda 2. So this is your Snell's law for different case in terms of refractive index, in terms of velocity, and in terms of wavelength. Now let us discuss one more thing. If this is your incident wavefront, ये आपका incident wavefront है, and it is emerges out. Now, and if this incident wavefront is a normal, if both are in this plane of blackboard, then the ray of a light which is get refracted will also be in this plane. It will not strike back in another plane. So for that, this will not be a normal. It means that all the three rays should lie in one plane. So this is your all about this much. Thank you.